Welcome to this latest in our series of webinars. Today we're trying a whole new format in which I'll be joined by my colleagues Marc Muick, who is going to tell you about the new UltraCam Osprey 4.2, and Bernhard Schachinger, who's giving you his latest insights on UltraMap version 6.6. For those of you who don't know me yet, I'm Schoderer and running the Asia Pacific region in sales. This webinar will be recorded, and I ask you to fill in your questions on the right side in the panel so that we can answer them in the end. Let's get started. Welcome, Marc. Good to have you here today. We recently launched our new Osprey 4.2 large format oblique camera system, the successor of the Osprey 4.1, which is in the market for quite a while now. It's an evolution, so both cameras share some of the common specs and feature the same components. What comes to mind is, for instance, that they both have a panchromatic channel still. They have the same housing concept and dimensions, for instance. Same frame rate, 0.7 of a second. They have the oblique image mode, which we introduced a while ago. And last but not least, all the external hardware components, like, for instance, data units, transfer stations, and so on. The main difference, I think, is in the new sensor, the Sony IMX811 that came to market recently. Could you tell us what's so special about the sensor?
Absolutely. So thanks for having me. Yeah, what makes the sensor special? The pixel pitch is very special. So it's a 2.81 micron pixel pitch, which is really fine to have in our industry because it directly translates to being more efficient. So since you already mentioned that comparison to the Osprey 4.1, so here with this new sensor and the smaller pixel, we're roughly creating an efficiency jump of 27% in that magnitude.
Okay.
And so that then directly translates into a footprint size that is 25,000 pixels across the flight strip and also 19,000 pixels along the flight strip. And that format is kind of interesting because it's more or less getting into the shape of a square, and that means that we can really benefit from having an awesome geometry and awesome reconstruction, delivering high quality DSM products, DSM auto products, all that good stuff.
Cool. There's talk in the market that the smaller pixel sizes result in a lower sensitivity of the sensor. Is there anything to that?
There is something to that, but the, let's say, talk that was, or the information that was somehow spreaded here, was linking that the direct connection between the smaller pixel and light sensitivity loss, and there is no direct connection. So if my pixel is 1.8 times smaller, so compared again to our Osprey 4.1, that does not mean by any chance that this sensor is now 1.8 times less light sensitive. That's certainly not the case, because obviously then we would have a problem, but that's not the case. What we found out when we did the investigations of the quality of the sensor, we did experiments and multiple of those. So and I think the really best setup that you can have when comparing sensors between each other is basically having the same environment around them. So we, in our controlled environment in our laboratory, we have a light source that is constant. We are using the exact same lenses, and by exact I mean literally the exact same lenses, the same shutters, everything is the same. We really just swap out the sensor. And that's the best apples to apple comparison that you can achieve. When we do this and we check what the outcomes are, it's pretty magnificent because the light sensitivity loss is just 10%, which is really not much. If you think about what that means or how that translates into signal-noise ratio, that is just a difference of 3 dB. So basically meaning half a bit, and this is really like nothing in real life. So from this kind of basis, what the sensor gives us, we did not even see the necessity to change anything in our kind of approach to exposure, to shutter speed or anything in that regard. So all that, as you said before, is the same with the Osprey 4.2 as it was with the Osprey 4.1.
So you're saying that despite the smaller pixel pitch of 2.81 microns, that the Osprey 4.2 still delivers the same image quality as the previous version? How do we achieve this?
We talked about the sensor already a little bit. And we also talked about the pixel pitch a little bit. And I think this is somehow here a good translation to the lens topic. Because if you have a smaller pixel, that means that you need a higher resolving lens than for a bigger pixel, for example. Right? So and therefore, we need custom-made lenses that are designed specifically for our application. For example, they are temperature compensated, which your normal lens for your camera, for example, is not. So highest optical quality is essential. And since we're already talking about lenses, you might ask yourself, okay, why are we using the same lenses for at the Osprey 4.2 as we did for the 4.1? Because we can. And why can we? Because we over-specify our lenses during the design process quite a bit, so that they're at least safe for 1 or 2 versions. And we try to roughly estimate what the next sensor generation, so to speak, will deliver, and therefore adjust our specifications of the lenses. So the lenses are super important to deliver awesome quality. And then, of course, we also have a software side that needs to work together to deliver this quality that we are known for. There, I think we should talk a little bit about our true pixel processing, so TPP as we call it. And that's our idea to take multiple steps of image processing. So, for example, debayering, denoising, all that stuff that normally happens sequentially, and try to solve that in kind of a holistic approach. So basically solving everything at one go so that these pieces can interact with each other. And also one of the most important parts of this big holistic approach is also the adaptive motion compensation. So basically our software-based method to deal with motion compensation or motion blur, so to speak. And as you know, this can compensate for movements that come basically from the forward motion of the airplane, so the forward motion compensation. But also it can compensate for any humps and bumps and angular changes that happen during flight. And I think here, especially with AMC, it's really worth mentioning because sometimes I think people just get that wrong. Sometimes people ask me, okay, I'm using a mount anyway, and it should compensate for the angles, right? Yes, in theory, and it compensates for the angular movements of the plane, yes, but in a way that our footprints and overlaps are as planned. It's not the motion compensation method, so to speak, right? So you cannot move a 70-kilo camera, certain mass with a certain inertia in it, right? So you cannot move that in parts of a millisecond to exactly what the airplane is doing. So that's just too heavy to do that. So this is where our adaptive motion compensation, I think, really shines and really gives us this opportunity to go in, capture the image, and just get it. And it's done for one go. There's no reflights needed. We get it. We go in. The flying is getting harder. ATC restrictions are getting harder. It's just becoming harder than it used to be. And so we want to have some approach that gives us basically this capability. And that really all together delivers the image quality that you can see and use for your follow-on products, like DSMs, DSM Moto, all that stuff.
Cool. Sounds like a real game changer for us.
It certainly is. Yeah, in terms of efficiency, that certainly is the case, and we can maintain the quality that we are known for.
Cool.
I think that's the.
I'd like to talk about the arrangement between our nadir footprints and our oblique camera systems a little more. It takes a little more than just assembling single camera heads together, right? If we want a well-balanced geometric perfectly system, what can you tell us about that?
I think it makes sense to start with how the focal length between nadir and oblique should play together. Every oblique camera that is currently on the market, we're using a 45-degree angle for the obliques, and obviously having a 45-degree angle leads to a longer distance for the oblique cone to look into the world, and that distance is based around the factor of a square root of 2, so roughly 1.4 is that factor. And this is what the oblique cones must be longer in focal length than what their nadir counterparts are to get the same GST, because what you want to have at the end of the day is when you're doing your flight planning, let's say normally this is done with the nadir cone, and you plan for a 5 centimeter GST, then obviously you want to have more or less the same GSD in the oblique, which is somehow not really possible because there is a scale in the oblique image, so a transition from front to back in terms of GSD anyway. But at least in the center where we measure what the GSD of the oblique cone should be, we want to have a balanced approach to that.
Right, but some other systems have very wide nadir footprints. Why don't we do that?
Yeah, as we, let's say, like to work on sound photogrammetric principles,
right.
The efficiency of an oblique system is somehow defined in the forward and backward oblique and what their size across the flight strip is. Since the oblique cones are smaller than their nadir counterparts in terms of its footprint, by moving around, moving the nadir part too far apart, that would create some kind of small gap in the oblique overlaps. And this is not the case with our setup because our nadir footprint size is matched to our obliques. So if we fly a 60% overlap, for example, again, we roughly end up with in a 20% plus range of overlap in the oblique still.
And we're still doing another very smart thing, I believe, where we, due to our large the cone circles, we can shift the sensor up a little bit, right? What does that do for?
Yeah, absolutely. So, as you might obviously already explained correctly, every lens is projecting a circle, and within that circle you can arrange the sensor basically where you like. You can do it in the center, or you can move it around a little.
Right.
And so for our left and right-looking oblique cones, we decided first of all to use them in a portrait mode because that just makes more sense to get more, to get a better coverage basically. And we also shift the sensor slightly towards the airplane, and that basically results in covering more ground with a more meaningful GSD because you want to have like the better GSD, the better imagery. You're not too much interested in stuff that is going up towards the horizon, where my GSD is getting lower anyway.
Right,
yeah. So.
Last but not least, I think it's very important for the audience to understand that the Osprey 4.2 is available in two different lens configurations if you want. While the Eagle 4.1 has an exchangeable lens system, here the customer has to choose beforehand, before he makes a purchase. The standard version comes in an f80 f120 millimeter configuration. Again, we always have longer focal length on the obliques because the objects are further away from the sensor. And the tele version has an f120 and an f180 millimeter focal length. Can you explain what what flight altitudes this results in?
So the smaller the pixel gets with the same focal length, the higher flying altitude will be. And to give you an example, for the Osprey 4.1, for a planned 5 centimeter GSD, we would fly roughly around 1,000 meters above ground level. Doing that for the Osprey 4.2 will result in flying at 1,400 meters. So you see that this is just basically the shift that the sensor creates in terms of flying altitude because the lenses, in terms of their focal length, are the same. Having this higher flying altitude here maybe helps a little bit in terms of maybe climbing above certain ATC restrictions. But if that is not enough, we have the longer focal length option as well with the 120 and 180.
Can you tell me what GSD that results in? Let's say we want to fly 5 centimeters, what altitude?
Yeah, sure. So if we do the same exercise again, the 5 centimeter GSD for the Osprey 4.2 with the 180 millimeter lens, we would end up roughly around 2,100 meters above ground level.
Well, and in the end, there's a difference in the design of the oblique cones in the two different versions, standard and tele. Can you say one last word on that?
Yeah, sure, happy to. As you can imagine, longer focal lengths, obviously also the lens itself is larger, and therefore we need to arrange them slightly differently. So with the standard lens, so the 80 and 120 millimeter combination, the 120 millimeter lenses are basically arranged in a way that they are looking through the center of the camera cylinder. And this is not the case or not possible with the 180 mm lens because they're just too long to fit in our cylinder that way with the 45-degree angle. Therefore, we basically move them from the center of the cylinder out to the border, and they're arranged on the side basically. That's perfectly fine to do. The only thing that you should consider is using a unit lifter with it.
Right. The unit lifter we offer allows you to basically pull the camera in during takeoff and landing and push it down while you take the
We also have some oil springs in it, so it's easy to lift up and down.
Yeah, cool.
And that makes sense to use with the longer focal length.
Great. Cool. Thank you, Marc. Important for our customers to know is probably at this point that we offer an upgrade path, so you can physically keep your camera and upgrade your system from 4.1 to 4.2. For pricing, please contact your sales representative responsible for your area. Marc, I'd like to thank you very much.
Thank you. My pleasure.
It was a very interesting talk.
My pleasure.
Hi, Bernhard. Welcome.
Hi.
Good to have you here today. We're obviously there to talk about the latest development in our UltraMap workflow. We recently released UltraMap version 6.6. As we all know, high-end data like we get from the Osprey 4.2, which we talked about just in the previous conversation with Marc, we require that data to get the best derivatives we can get out of our UltraMap software workflow, which consists of the Essentials module to download the data, process it to level 2, go into the AT, then to the dense matching where we create point clouds, DSM derivative DTMs, the ortho pipeline, and last but not least the 3D module. Today we want to focus on these latest news on the 6.6 version, where the development team put all the effort into water handling, DTM algorithms, and the 3D module. Let's start with the water handling. What's the general approach Vexcel has to water handling?
Yeah, we consider water handling to be very important because water does have some serious impacts. On the one hand on the radiometry of the images, just think of reflections of the sunlight on the water bodies. And on the other hand, dense image matching suffers from water bodies because image matching is just not that easy on water. So our approach for the water handling consists of a few steps. First, there's segmentation of the image data to identify the water bodies. And then we do a flattening of these water bodies, so automatically deriving height of the water level. And then in a third step, all these water bodies with correct height are used on the one hand in the color balancing, and then on the other hand in the DSM and DTM.
And what's now the main difference between the old version and the new version?
In the new version, we can now benefit from an improved image segmentation. So all the water bodies are now detected in a more robust way. And then, in addition to that, the calculation of the height of the water bodies is now also more robust, more precise than in the earlier version. And third, small islands and rocks in the water, they are now also handled in a better way.
Great. Can you maybe show the audience some examples?
Yeah, I brought here a data set from Miami. So this is the area with a lot of water, and now we see here in blue the water mask that was created automatically by the software. So the water mask, of course, it does include the large body of water. To the right hand side here, the sea, but it does also include all the small areas within the city area of Miami. So these ponds, but also the small water here in this golf course, for example. And this water mask is then used together with the low resolution DSM to create flat areas for all the water.
Right. So you said previously this was all done automatically in the software. What if a customer needs to manipulate that data, change something? Is there like an editor as well?
Yeah, yes, of course. So the automated results, they work very well in a lot of cases, but there are situations where some refinement needs to be done. So for that, we do have an editor available. Just switching to this data set to show that to you. So here we have the low-res ortho in the background with the water mask now being displayed. And I would like to select here a few tiles that I'm going to load into the editor. In this editor, we see in 3D the low-resolution DSM with the overlay of the water mask. And in addition, we do also have a low resolution orthophoto before color balancing, therefore still a lot of differences in the images to be able to easily understand the situation. And that simple editor allows to modify the water mask. So an area can be added to the water mask in an easy way,
Right.
so that then is then treated as a water body. And we have a tool to modify the height. So I'm putting here now just 5 meters for the new water body. And now with that polygon, I can intersect this new height of 5 meters with the water mask.
Mm-hmm.
And all that area that is now treated, that gets this new height for the water.
Right.
So that is now done here in low resolution.
Mm-hmm.
And then when continuing the workflow, when going to the full resolution processing of DSM, DTM, then the pixels at the outline of the water body, at the borders of the water body, these are then processed to full resolution,
Right,
and
right,
using
right.
the confidence values, they are then being used in a very precise way to describe all the features along the water.
Very cool. I assume this already saved the customer a lot of time and effort in their workflow, and thus saves a lot of money down the road. I assume you can also export and import these watermarks if you, for instance, for future projects, you don't have to do all the editing and processing again, right?
Right, yeah. So watermasks can be imported from an external source, any vector data, or we can export the watermask from an UltraMap project and then reuse that watermask in a new flight of the same
Very good,
area to not need modification of the water bodies.
All right, moving on. Let's talk about the new DTM algorithms. They sit in the dense matching module. Can you tell us a little bit more about those, please?
So that consists first of a step to run the dense image matching to create the DSM, the digital surface model. And then for the DTM, the software is doing an image segmentation. So the result of that image segmentation is a map with all the trees, so high vegetation, buildings, roads, water, moving objects like cars, and so on. So we have a very good land cover classification, which is the input for the DTM algorithm. So all the objects above ground, above terrain, are being eliminated from the DSM, and then these areas are filled, are interpolated with new height values.
Right.
And that is then the DTM, which we can use in the further workflow or also export.
Great. So can you tell us in detail what's the difference between the previous version and the current UltraMap version 6.6?
Yeah, so for the DTM, we have implemented a lot of great new improvements and new features in this algorithm. So for example, we have been working on the water bodies also in the DTM. So as we have heard earlier, there are some improvements in the water handling workflow, and all these bring also benefit to the DTM. Besides that, even more important, the land area, that is now handled in a greatly improved way.
Right.
So now we are seeing the DSM of that data. So now in the ortho we are seeing agricultural land and forests and this valley with the little river. And now in the DSM we see with these colors the differences in the height. And this is a very challenging terrain for extracting automatically the terrain from the surface model.
Right.
So the new software that greatly supports now the extraction of the DTM by enhanced image segmentation. So we are using all these classes that we have been talking earlier, and also within the forest area we are now using all the single pixels that are seeing the ground and try to make benefit of those. And that allows us to follow then this terrain, get rid of the vegetation, but still get all the details of the shape of the terrain. So I would like to switch now to a 3D view to show that a bit more clearly. So now I'm loading all that data into the editor. And here we see in 3D this beautiful area. So that is the DSM, where all the trees, all the vegetation is included, also all the buildings. And now switching to the DTM, we see the terrain. Switching off now the ortho layer and showing you this mask. This mask shows us with the blue color all the areas from the DSM which are removed, so objects above the terrain level. And the light blue, these are areas that are filled from the DSM and that are then higher in the DTM. So all these local situations, they for some reason need that. That allows us to create a high quality DTM in this photogrammetric workflow just based on image data from DSM to the DTM. Another great improvement was done to traffic infrastructure. I would like to show a small area here where there are a lot of roads and also terrain changes. And the DSM, of course, includes the surface, so all the vegetation, the embankments, the roads, underpass, overpass, all that is included in the DSM. But that is also now included in great detail and quality in the DTM. And also the surface of the roads, that is made very smooth to avoid any distortions in the orthomosaic. Because any distortions, any noise on these flat surfaces, that could create some wavy lines, wavy road markings. And that is greatly reduced now with this new version.
Cool.
Then another very important topic are bridges.
Right.
Yeah. So bridges, they are important features in the DTM because there might be some cases where a bridge should be included in the DTM or is not required.
Yeah, if I can just ask you, well, why is that important? I mean, you sometimes see the DTM including a bridge and sometimes it's removed. What's the background here?
Yeah, so it depends on the use case for the data.
Okay.
So on the one hand, including the bridge, that makes it possible to create a DTM ortho of high quality. So these pixels of the image of the input image are projected in the ortho on the height level of the bridge, so therefore not distorted. If the bridge is not included in the ortho, then the pixels of the bridge are projected on the terrain, so they get an incorrect height and they are distorted in the final ortho.
Right, so basically if you take the bridges out, you can do like run-off models, hydrological application stuff.
Right,
Yeah.
so if the bridges are not included in the DTM, then such a DTM allows to model the flow of water.
Right, okay, thank you.
Here we see the valley with a lot of forest, where there is the bridge crossing that valley. Here's that bridge in the DSM. And now in the DTM we see that bridge as well, highlighted in yellow color. So the software is doing an automated detection of the bridges. And that automated detection, that allows us, or that allows the operator to activate or deactivate if the bridges should be included. So that is a switch that is controlling the automated workflow. Now in this new version 6.6, all the tiles that include bridges, these can now also be selected in an automated way. So now the tile selection tool here has a new button, a new filter to get all the tiles with bridges in an automated way. So for any QC that is required for a data set, this greatly helps, and also for any reprocessing tasks, this also helps. Yeah, so for the DTM ortho, for the ortho mosaic, we have been working on the seamline algorithm. And here we see now a map of all the input images for the automosaic for this data set. And the seam lengths are now placed in an optimized way. So the algorithm is taking advantage of the information on height now a little bit different than in earlier versions. And that allows to reduce distortions in areas where there's quite steep terrain and big changes in the height.
Wow, it sounds like we made some real improvements on the quality of the DTM here. Can you tell what's the benefit of using this DTM?
Yeah, so a great benefit is that with just one single flight, you capture all the data. So you capture the images, you can derive the DSM, the DTM, all from one flight and one sensor capturing the data. Also, all of that is created within one workflow. So any editing steps, they are also pretty consistent in between data products. And all these benefits, they greatly increase the quality of the output product, but at no additional processing time.
Oh, okay, cool.
And also for being able to implement all these improvements for improving the image segmentation, we have been using data from VDP, from our data program. So we had access to global data coverage and using therefore imagery from all regions of the world, from varying flight patterns, flight designs, to be able to cover all different kind of scenes and scenarios to make this algorithm as robust as possible. Considering all of these improvements, we are very confident that this is the best possible DTM that can be created in an automated way from aerial images.
Okay, I like that statement, definitely. And I think with this we can lead over to the last point of discussion today, which is the improvements to our UltraMap 3D module. Maybe you can give us an overview on what improvements we've made there.
Okay, a few words on the data quality and data structure itself. So we have been working on the texture in the 3D mesh, so that is now sharper than in earlier versions. We have also been working on the seam lines for how the textures are created from all the single input images. So there is now much smoother transition from one to the next. That's greatly improved. And we have also been working on the triangle structure in the mesh. So now there is a more simpler and less complex structure of all the triangles, with lower number of triangles. I can show you here the triangles, for example. So loading now a few tiles. So in this viewer, we see the 3D mesh without texture here, and these are all the single triangles that are combined for the full final mesh, and the structure of these triangles that has been greatly improved now with this latest release.
Are we talking about having more triangles or less triangles than in the past?
So that's now less triangles.
Less triangles.
So that means a bigger flat surface is now represented by a lower number of triangles. Okay, so then we have been working on some other steps in the workflow. And for example, the robustness and the performance of the processing, of the automated processing, that has been greatly improved. We have also added support for reprocessing of data. So this reprocessing, that follows now the exact same concept as we have also in our dense matcher and ortho modules. So single tiles that we see here can be modified and can be reprocessed. So not only reprocessing of all the data set as we had earlier. And then third, we have also added now an option to edit single tiles in external software. So with these buttons here, single tiles can be exported, then third-party software can be used to modify the geometry of these tiles, and then these tiles can be imported into the UltraMap software. And then, for example, new textures can be generated for the mesh by the UltraMap processing in an automated way.
So you showed here you can mark certain tiles. How about export? If a customer, for instance, wants to export a certain block of buildings or even one building alone, can they also use shapefiles, import shapefiles?
Yeah, so shapefiles are supported at various stages in the workflow. And for example, here in this polygon management tool, either shapefiles or polygons can be created or they could be imported. So for example, that allows to define the region of one particular building and then use that building for processing and exporting and handing over to a client. Besides that option, we have also extended the other options for the data export in a great way. All of these file formats, of course, can take advantage of these free-form map sheets, as we see it listed here in this line. And now, for example, the new format Cesium 3D tiles is available for UltraMap. And also, we have added now for the point cloud export the option to create RGB and colored infrared points. Besides the data export improvements, we have also been working on the user interface within UltraMap. So the viewer has been changed slightly to now better match the user interface that was also known in the dense matcher and auto modules. And here we can now change the view in between a few layers. And then on these layers, it's basically either a top-down view of the 3D mesh, the DSM, or the textured version of the dataset. Based on that, the user can select tiles and then load into the viewer. And here in this viewer, we have then the wireframe views, as we have seen already earlier, also available now here with texture or with solid texturing for the full triangles with full image content. And due to the improvements on the data structure itself that we have discussed earlier, now also the visualization of the data is much smoother and reacts much faster than before. So here's an untextured view, here's the textured view, and we have seen the triangles earlier.
Very nice, very nice. So in summary, we could probably say we made big improvements on the data quality in 3D, on the processing workflow, and last but not least, also improvements on the user interface, right?
Right.
Correct. Great. Thank you, Bernhard, for that. Appreciate your time today.
Thank you.
With this, we come to the end of the webinar. If you have any questions, please type them into the Q&A pane you see on the right side. We will now start the Q&A session. Everybody there, yes, hello and welcome to the Q&A session of this Tech Talk. Marc, Bernhard and I are now live here to answer your open questions. As I just said in the recording, if you haven't done so yet, please, this is the perfect time to type in any of your open questions on the right side into what's labeled there as the Q&A section, so that we can now go through them. Let's see what we have here already. Hold on a second. So there's the first question here. What kind of GNSS INS integration is recommended for best results with the Osprey 4.2? Well, Marc, I think this is one for you.
Yeah, I'm taking that one. So for best results, it's basically also the question what you're doing. So basically, are you targeting direct georeferencing or are you working with ground control points? If you're aiming for really working with direct georeferencing, then I would vote for having a POS AV610. That would give you certainly the best quality. If it's a mixture of using GPS INS together with ground control points, which is, let's say, more of the standard approach, in that combo, I would say that a 510 setup is also perfectly fine to use.
How does the Osprey 4.2 handle fast aircraft speeds?
Yeah, I'll also go with that one. So just as well as our Osprey 4.1 does. So you can easily fly let's say 5 centimeters with 200 knots. That's certainly not an issue. Customers have done that with the 4.1 in the past. So pretty much comparable. No differentiator there.
Which sensor do you integrate for the bi-color and near-infrared images of the nadir subsystem? Are they IMX811 from which you only use 185 megapixel among the 247 megapixel, or are there some specially designed CMOS sensors of 185 megapixels? Marc, do you understand the question?
Sure. So here we are using just 185 megapixels of the 247 for the reason that the focal length on our nadir infrared and color cones are slightly shorter than they maybe, let's say, need to be, and therefore their footprint is just larger than what our panchromatic image is. So this is basically just using what we need, and this is then translating into those 185 megapixels. So it's not a custom design sensor.
Which of your cameras will be the next one to migrate to the IMX811 world? In other words, will the UC Merlin 3020 4.2 be the next system in 2026? I think that's a question I can answer. I can't provide too much input on this topic yet, but it's fair to assume that we're looking into implementing the new sensor into the entire UltraCam lineup. When and which camera will be next is currently being assessed by our development team. So please bear with us for a little longer. I would probably expect news around Intergeo later this year. In reference to the classification that is performed on the DSM data, in brackets trees, houses, cars, bridges, is this classification information saved out when you export the point cloud? Bernhard, I think that's for you.
Yeah, so at the moment we use a classification of the data which is specifically tailored to the water handling stage and to the DTM algorithm. So for that reason, because this is like custom made to best serve these algorithms, there are classes which we think do not yet make too much sense if we export it right away. But we are thinking about how we can combine all of this classification data that we have to make some meaningful exports. So yes, we are definitely looking into that option.
Can you show a textured mesh? Well, I think it's pretty tough now in this current setup. We have textured meshes now on our homepage to look at, right? The exported Cesium files directly in the browser, but I'm pretty sure that Bernhard is happy to provide more data on demand here, right, Bernhard?
Right. We do have sample data available on our website and also for download from the FTP. And I'm also happy to share other data if there is interest. So just please reach out after the webinar to us.
Those improvements in the DTM processing include all generations of UltraCam, Eagle, for example. Thank you.
Yes, so these improvements are not specific for any particular camera type. So all UltraCams benefit from this new algorithm, and yeah, the data from all UltraCams can be processed with the new software version. So even going back to the old UltraCam D, UltraCam X, and so on, all of our cameras can be processed and take advantage of the latest developments.
Any new imagery LiDAR sensors coming, preferably a larger area hybrid LiDAR camera covering a larger area than the Dragon? Well, as I said earlier, we're currently looking into all kinds of directions on how to implement the new sensor. This is the wrong time, I guess, to talk about it, as we're still under assessment and development is testing configurations and such. So you will be the first one to hear. Announcements are typically also made at Intergeo, so I would kindly ask you to wait a little for what's coming next in another 1-2 months. Are there performance gains when processing large data sets, particularly for 3D mesh generation? Bernhard, that's for you again.
Yeah, so with this UltraMap version, we have changed quite big parts of the processing. So on the one hand, for the DTM, there is now a lot of different things happening than in the old algorithm. And we always had there the focus of increasing the quality, but not increasing the processing time. And for the 3D mesh, also similar, For the 3D mesh with this release, we mostly had the focus on processing performance improvement and increasing the robustness of the processing. So yes, there are performance gains for 3D, and these are significant compared to earlier versions, plus adding robustness and a few other benefits. So it's a big step forward for the 3D mesh generation.
Artificial intelligence intervenes at some stage of processing. Is that a statement or question? Both, I guess. Bernhard, can you say anything about artificial intelligence now post-processing?
Yeah, there's a lot of intelligence in this processing, and a lot of these algorithms are now based on machine learning stuff. So we heavily rely on machine learning for the image segmentation, which we use in the water handling stage and in later stages as well, and also looking to increase the usage of these intermediate results also to other algorithms, and not only that, but also other things. Yeah. So currently, we are taking advantage of certain pieces, and definitely more to come. And just to give some idea of what that means using machine learning for the image segmentation, we are using a lot of data from all over the world with varying GSD, varying flight plans, different UltraCams being used, which are provided by customers worldwide. And on the other hand, we are using a lot of data from VDP, our Vexcel data program, where we also have coverage from a lot of different regions in the world. And that helps to train the algorithms to tell the software what different land cover looks like, and also flight parameters and so on. And that all contributes to the robustness of the algorithms.
Do you have any recommendation on back-end and front-end hardware?
Yeah, we do have some recommendations, or let's say we do have some minimum requirements for backend and front-end hardware. It's mostly up to the projects and the requirements on timeframes and so on, and also typical project size for what might be the best system. So if you have any specific requirements in terms of amount of data to be processed in some amount of time, or some other project requirements, please reach out to us, and we are happy to provide information and find with you the best possible setup for your requirements.
What GPUs do you all recommend for very large area processing?
Well, UltraMap is now supporting all the major GPU generations that are out there. That is not an easy question to answer, because it more or less depends on the other components in the system. So if your processing system is a huge system with a lot of CPU cores, that needs to be taken into consideration when looking at GPUs. So it might be either make more sense to use less GPUs, but these are very powerful, or more GPUs, these are not that powerful. So I would not only look at the GPU itself, but rather the entire system where the GPUs should be integrated. And also for the particular GPUs, the price to performance ratio, so that you make the most out of the money that you invest into these pieces of hardware. Because GPUs can get very expensive, but not always. Only the most expensive GPU is the best one to fit into your system.
What does it take to upgrade the Osprey 4.1 to 4.2? How long is the downtime? Well, it definitely takes the new sensor, and the downtime, I can say one word about it. That depends a lot on the workload at that time. A couple of weeks, definitely. The camera needs to go back to Graz and Wild. But maybe, Marc, you can say a couple of words what else needs to be replaced.
So if we think about the new Sony IMX811, there is one difference to the 411, except for the smaller pixel size, and that is that the form factor of that sensor changed slightly. So the shorter side of the sensor shrunk a little bit, and therefore we also have to basically install a new sensor carrier with it. So it's basically not just switching out the sensors, also some supporting hardware around it, so to speak. So you can basically compare that. I think we're doing open heart surgery here on that patient to get him up to a new level. And that takes some time, but also not able to give you an exact number of what the downtime that is.
I would ask you to contact your sales representative, and they can then work it out with our team to narrow it down to the time, to final time frame. Are the newer AI-pointed GPUs efficient at DSM processing, Bernhard?
Yeah, I would say similar to the answer from before. It depends on the overall system configuration and the other components. If such a high-level GPU brings benefit and how much it brings benefit, and if this benefit is worth the money or better to invest this money into some other configured GPUs. So it will make sense to have a look at the entire system and also at the typical projects that are being processed. And then we can give a recommendation on the best GPU to use.
Here's another one regarding the upgrade. Can the upgrade be done in Denver?
I can take that one. The answer is simple: no, it cannot.
It needs to go back to Will, right?
Yes.
That's my understanding because of what you just said about the carrier.
No,
it needs to go back to Austria.
Yes, exactly.
Best way to reach out. Depending on where you are, you can find the sales and support team email addresses on our website. Yeah, email or call. It's all on our homepage. Can we use the new UltraMap feature to improve older projects? Bernhard, this is clearly addressed to you. Could you comment, please?
Yes, so all the projects, all the data can be used with the new software version, can be processed with that. However, it needs to be taken care of that at a certain stage, you start with the data, the processing. So to take the most benefit out of the new features, we recommend to start from the stage before the water handling. And therefore, you can make then sure that all the information required by the new DTM processing is generated and you can take full advantage of that. So you can use existing error triangulation results and then start from there the processing. That is the recommended way for the best possible results. However, if you do have already data sets being processed to DSM authors and so on, and you want to just export some data, that is supported without any limitation, of course. So you can take any projects from all the UltraMap versions, load into the new version, export the data, and you are fine.
With the updated DTM processing, are we looking at a higher resource demand, also Bernhard?
Yeah, so the processing changed a bit compared to the old algorithm, of course. But we had the clear focus in mind that the overall consumption of processing resources should not increase. So the overall consumption of processing time is very, very comparable to the earlier algorithm. The structure of the processing tasks changed a little bit, but overall there is no significant difference. Also, the processing hardware does not really need to be prepared in any different way. So existing systems can be used, and calculations for processing time, they are still valid, as there is no significant change.
For heavily forested areas in tropics, does this new image segmentation able to derive a good DTM? And is there manual editing features in the software?
Yeah, two very important parts are there in this question. So for the first part, for image segmentation, we can answer that with yes, as long as the image data somehow allows to see ground. So even if there are a few single pixels showing the ground in between the trees, then that's good to go for a DTM. So the new algorithm is heavily based on improved image segmentation. A lot of training was done, training with data from regions from all over the world, benefiting on the one hand from data which was submitted by our customers that we could use for the training, and on the other hand, data from our data program. So regions from all over the world have been used to train the algorithms, and also various camera configurations and so on. So as long as the data allows to see some of the ground, we can use that. And for the second part of this question, for the manual editing, yes, there is manual editing both for the DSM and the DTM. So small areas can be modified, larger areas can be modified. And if there are situations where forest does not allow to see any of the ground, then you could import the DTM from an external source just to replace the DTM, the internal DTM in that region that DTM comes from others. So there's a lot of flexibility now in this regard.
All right. In the end, you were breaking up. I'm not sure if this was either to everybody or just me. I hope everybody was able to understand it. Otherwise, please just contact us directly, and we can answer those questions as well later via email. Any chance UltraMap is able to process aerial photos from various camera sources? Well, I think I can take this directly. This has been, well, a question we get asked a lot, and it's a political decision to so far not opening up our software. We keep an eye on it. There are certain reasons why we do it the way we do it. It's proprietary to our UltraCams. One of the key reasons is that we know how to maximize the output out of our cameras. We want to have our customers benefit from what they get using the combination of UltraCam plus UltraMap. That doesn't mean that we are not looking into that and maybe do something in the future, but for now, the resources are used to improve the current UltraMap wherever we can, and we'll see where we go with that. May you show us a topology of 3D mesh processed in UltraMap version 6.6? Bernhard?
Yeah, happy to do so. It's a bit difficult to do that right now here in this Q&A session, but I'm happy to follow up. So just get in touch with us, and I'm happy to show you that.
Is it possible to use an external point cloud, LUS, or any other format to create texturized 3D models?
Yeah, so for the 3D workflow, we have now added the capability of editing the data with a workflow to export some data, modify it in third-party software, and bring it back into UltraMap again to take advantage of modified geometry for texturing and so on. So this does not only include a modification of the data, but this could also be used in a way that some external data is being either combined with the data that is taken out of UltraMap or is replacing that. So yeah, there is now a workflow for doing that.
Can we expect other camera support rather than UltraCam in version 7? Bernhard, I'm not sure what's on the roadmap for version 7, but again, I think this is similar to the question we had before on opening up UltraMap. I would guess it's the same answer, right? Not at this point in time.
I agree. It is the same answer like for the earlier question. There are a lot of features on the roadmap for version 7. We will talk about that when there's the time to do so. But for now, regarding other camera support, this was answered earlier.
Here we go. You mentioned that regarding overlap in the Osprey 4.2 for a 60% in the nadir, we should expect around 20% in the obliques. Is there a minimum overlap in the nadir images to reach a certain overlap in the oblique images and avoid no overlaps? Marc, this is to you.
So I guess this is a simple one. For the, let's say, standard site overlaps that you will see in tenders, this will not be something where you have to like focus really on. So the geometric setup of the nadir and the oblique will take care that this is not going to happen. So even if you spread it out more, that will not be a problem.
How do newer sensors handle glass, glare, and distortion?
So in terms of, if you mean with glass glare that you're talking about reflection, so this is pretty much then dependent on the anti-reflection coating that is used. And I think Sony is doing a very good job with that in general. In terms of distortion, I'm not sure where this is going to, but anyway, distortions within the sensor that can occur. We take care about that in terms of how we model the sensor and its behavior, and also in terms of the geometric properties that these are calibrated anyway with our calibration. And these models that I was talking about, they are also interacting with the calibration. So I think we got you covered really well in that regard.
One last question from my side. I've heard about local reprocessing being used for certain workflows. What's the actual benefit of doing it that way?
For all the data products that UltraMap is generating, so the DSM, DTM, orthos, and also 3D, we offer a user interface and tools to control certain regions that were processed fully automatically, and then also edit these. And we try to implement a user interface which is making the human effort as smooth as possible. There is definitely some human effort, so we just cannot avoid that to control and modify any data, but with the benefit of doing some work that is needed and then reprocessing if there have happened any edits, then reprocessing this area with the edits in an optimized way, reprocessing on the one hand just these small areas where edits have happened, and also reprocessing at the right time for the user. So example for the auto processing, auto editing and processing, there could be a collection of a few edits, and then during some break time, these particular edits could then be processed just all in one row to optimize the time available for the operator and the time for the processing.
While having a seamless mosaic over the water bodies, do we still preserve the radiometric and spectral properties of the images in order to analyze spectral properties of water surfaces?
Okay, yeah. Water handling, that is now quite a big part of the UltraMap workflow, and the focus of the water handling is on making the orthomosaic as homogeneous as possible on land and on water. So the information, the pixel information on the water bodies, that is modified in some way to make differences in between single images as small as possible. That means reflections of the sunlight on water are handled in some way, different color tones are being handled, and so on. So that is optimization with the focus of a most homogeneous orthomosaic. On the other hand, if certain radiometric characteristics of the images are of interest and the image data should not be modified because that information is important, then this workflow could be done as well. I would see that as a separate path within the workflow. So if that is the way to go, the result desired by the client, it's fine. This could be one processing. If there is a need for both versions of the data, homogeneous data, but on the other hand also image data, which is radiometrically not that modified as in the other version. Then we also offer a path where the DSM, DTM processing can be done just once, and then auto processing could be twice for the radiometrically adjusted version of the data and for the other version of the data. So this is also supported in a way to reduce overall processing time and just process that amount of data that is required twice, just process that twice. So a highly efficient approach.
Do you have any plans to make a webinar about Dragon and its features and data processing from it? I think I'm going to take this directly. I would have to check with our marketing team on what's scheduled next in our webinar series. If this is of interest, we can definitely gonna look into that. And let's get back to you whenever we know more. I'm not sure about the exact schedule at this point in time. Do you have plans to use new GPUs, for example, Ampere, for processing? Bernhard, this would be to you again.
Yeah, so Ampere GPUs are definitely supported. We are also supporting also newer generations of GPUs. So to find out which ones are supported, please have a look in the release notes document. And there is a small section giving the requirements on the GPUs. So there is on the one hand the compute capability for CUDA and then the CUDA driver version. So there are these numbers for the versions that need to be supported by the GPU. And right now it's quite a broad range of GPUs that we support, ranging to almost the very latest models. So I think we cover there all from quite affordable GPUs to very high and very expensive GPUs.
Thank you very much for your participation out there. Also, big thank you to my co-hosts of today, Marc and Bernhard. I wish you all a very nice remaining day.